All right, this is the Chapter 7 test review. I put test up here, but this is the review that we have for it. The first couple here are asking us to simplify. We have the radicals here. We went over these in class for trying to simplify the square root of 72. We're trying to look for factors of 72 that are perfect squares. I might start to write down the factors. 4, 5, 6. Okay, so of these factors, we want to try to find the largest perfect square. There are other perfect squares. 9 is a perfect square. The 36 is a perfect square. In this example here, let's say you didn't automatically choose 2 and 36, and you chose the square root of 9 times 8. That's still going to work. For this x squared, it is a perfect square, so I'm going to separate it out and include it over here. We said that the product of the radicals can be written as two radicals that we're multiplying here. So it's like 9 x squared times the square root of 8. The square root of 9x squared is going to be 3x. The square root of 8 is, the square root of 8 can be simplified because the factors of 8, there's that perfect square in there. So I can rewrite this like 3x, let's use a different color, of the square root of 4 times 2, or 3x square root of 4 times the square root of 2. Now the square root of 4 is 2, so this looks like 3x times 2 square root 2, or 6x square root 2. This isn't the fastest way. An easier way to do this would have been using the square root of 36. But the reason why I'm showing you this is that if we have a number and we don't arrive at the largest perfect square, it's like bringing in the groceries multiple times. It might take us a little bit longer, but as long as we factor out all the perfect squares, this should work. If we were to use the square root, 2 and 36 from the start, this would look like 36x squared times 2, and then both 36 and x squared are perfect squares, times the square root of 2. This is like 6x root 2. With 96. There's 1 in 96. If I were to divide this by 2, it'd be 2 and 48. 3 is going to be 3 and 32. 4 and 24. 6 and 16. It's not divisible by 7. It is going to be divisible by 8. 8 and 12. It's not divisible by 9, or 9 isn't going to be one of the factors. 10 and 11. So I'm looking at the examples here. I've got 4 and 16. For this one, I'm going to pick 16 at the start. Now, p to the 5th, a perfect square would be p to the 4th, and I'm left over with 6 and then 1p. So I can rewrite this like the square root of 16 p to the 4th times the square root of 6p. What's inside the radical here can't be simplified, so this is going to be, what's inside the radical for the 6p can't be simplified. The square root of 16 is 4. The square root of p to the 4th is p squared. Think about it like it's dividing by 2. This is 4p squared, square root of 6p. Oh. Now for the cube roots, we have to remember our perfect cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 20. Sorry, 3 cubed is 27, 4 cubed is 64. So when I want the cube root of 54, I can't use 64. 54 is not going to be divisible by 8, but I can write it as 27 times 2, and then the x is going to stay there. Unlike the last example, let's say it was p to the 5th, I would break this up like p cubed and p squared. You'd be trying to find almost like dividing by 3 for the example here. Same thing with the square root. With the cube root, I can break this up like the cube root of 27 times the cube root of 2x. The cube root of 27 is 3, so it's 3 cube root 2x. And for this last one here, the square root of 54. Again, I might go through the factors of 54. 1, 54, 2, 20, 2, 27. If this is 3, it's going to be 18. 4 is not going to work because 2 and 27, there's another factor of 2. 5 is not going to work. We could do 6 and 9. So my perfect square is going to be 9. I'll break this up like the square root of 9. If it's p cubed, I can factor off p squared times 6p. Now it's the square root of 9p squared times the square root of 6p. And the square root of 9p squared is going to simplify to 3p, and the square root of 6p. For numbers 5 and 6, they're asking us to write each expression in exponential form. So if you have a radical of a root x to the b, or the index of a, and then it's raised to the b, both of these would look like x, where the numerator is going to be the b, and the index is the denominator. Be careful. Make sure that you're not writing just 3n to the 5/3. I saw this a lot last year. This is not telling me to raise 3 to the 5/3. This would look like 3n to the 5/3. Same thing over here. This is 4x to the, oh, sorry. I was looking at the wrong one. This is 3/5, where your index is the denominator, and the power raising 2 is the numerator. So the 5 is going to be my numerator, and I'm dividing by 3 from the index. If we were to go the opposite way with this, right, if it's v to the 5/2, you could write this like the square root of v raised to the 5th, or the square root of v to the 5th. You don't have to show me both ways of this, you just have to pick one. I think because the examples are shown in this way usually, most people will write the answer like this, but that's still true. Same thing with x to the 3/2, square root x cubed. We can't expect it's always going to be 2. It could be to the 3rd, it could be to the 4th. So for numbers 9 and 10, they're having us simplify, but they're not writing this radical form. They're starting off with the exponents, and it's up to us to write this like 27, a to the 9th, to the 3rd root squared. It is my advice to not raise these to the powers first, but to first take whatever the radical of like the square root, the cube root, and then raise the powers. I'm gonna pause the video here.